In this video we're going to take a closer look at our redox reactions. So some of this is going to be a little bit of a review, but we want to put it into context so that it goes with our chapter 20, our electrochemistry unit. So remember the activity series. This helps tell us if reactions will happen. So elements that are less easily oxidized will oxidize elements that are more easily oxidized. And this is going to go in conjunction with the electrochemical series as well. And you can do this one of two ways. One way we're going to look at here in this video, you can list the elements one on top of each other in order of increasing or decreasing activity. So obviously this is not a complete list here, but this is as you're going down, you're increasing the ease of oxidation. So potassium will most easily oxidize. And gold will not oxidize very easily. Like, for example, if you have a ring that you think is gold, but it turns your finger green, it's probably not gold. It's got some copper in there, because copper is going to oxidize easier than gold will. So any element is going to oxidize anything that's below in this series. Like, for example, copper will oxidize zinc. So the copper is going to be reduced and the zinc is going to get oxidized. So it looks like this. Because copper is above zinc in the activity series, that's going to make copper a stronger oxidizing agent. So the copper is going to oxidize zinc. So in doing that, the copper gets reduced. Remember, if one thing is oxidized, something else has to be reduced. Now the reverse cannot happen. Redox reactions will not spontaneously occur in reverse. Like the oxidation of iron is a redox reaction. Cars don't unrust, they just keep rusting. So zinc is more easily oxidized than iron. You can weld a strip of zinc to iron to prevent the iron from rusting. Like when you have galvanized nails, they've been coated in zinc so that they won't rust when you use them in construction. Alright, here's an example. Copper 2 nitrate is poured over solid zinc. So this type of problem can only be a redox reaction because the copper 2 is the only species that can gain electrons. So here is the half reaction for copper. So zinc is the only species that can lose electrons. Now what's the balanced net ionic equation? We cancel those electrons out and we get copper plus 2 plus zinc yields zinc plus 2 plus copper. So in the past we've simply been writing half reactions here and identifying oxidation and reduction, but now we need to put them together into one balanced equation. Halogen displacements are where halogens are bonded to themselves, can take away electrons or oxidize any halide ion that's below it in the family. So fluorine is the strongest here. It can oxidize anything below it, and if you look at the periodic table, these do go in order down the halogen family. So here's our example. Chlorine gas is bubbled through an aqueous solution containing potassium bromide. Now we're not going to include potassium because it's a group 1A metal. It's soluble with everything. So it is not going to react with the chlorine in solution. You would only get solid potassium chloride if the reaction was not in, say, water, a polar solvent. So chlorine is the only species that's going to gain electrons. So what's the oxidation half reaction? We're going to look at the bromine here. It's the only species that can lose electrons. So what is our net ionic equation? It's going to look like this. Chlorine can oxidize bromide because it's above it in group 7A on the periodic table. And this is actually the process that we get bromide from. We can extract bromine from seawater. We can also use the same process when we form solid iodine because chlorine is also above iodine in the periodic table. In a hydrogen displacement reaction, the hydrogen atoms in water are going to be reduced as they gain electrons to form hydrogen gas. And you can see that process here. We've got water and 2 electrons forming hydrogen gas and 2 hydroxide ions. So all group 1A metals, calcium, strontium, and barium from group 2A are going to displace hydrogen gas from water when they're in their elemental form. So when we put sodium metal in water, we first of all need to look at reduction and oxidation. So what's the reduction half reaction? That's where our water is gaining 2 electrons. So what's the oxidation half reaction? Our sodium is losing 2 electrons. Now we need to balance this by putting a 2 in front of sodium, sodium ion, and the electron. This is done because we need the electrons to cancel in the balanced net ionic equation. So one of the things we're going to be doing in Chapter 20 is making sure all of our electrons cancel out before we get to our net ionic equation. So what is our balanced net ionic equation here? In this reaction we do produce hydrogen gas, which we do know is flammable, and we can light that on fire.